Hey, I've got a quick integral here today from MIT 2013. This was problem 2. We've got an integral from -1 to 3 of e to the absolute value x dx. Okay, so obviously if this was e to the x, we get the simplest integral, but the integral of e to the x is e to the x. The only thing we're really dealing with here is this absolute value sign. Let's just take a quick look at how we can deal with an absolute value in general. Okay, so we really just have these two conditions, right? When for the absolute value of x, if x is greater than or equal to 0, we just have x. If absolute value of x, if x is less than 0, we can take the negative of x and then we've just reversed the sign. So all we really have to do here is we just need to break up our boundary. We just need to break up this integral into 2 and evaluate it when it's positive or negative. Okay, so here I've just split this up, right? For all of this is our positive region, so this is this case. When we have a positive region, we just drop the absolute value. We have our x, so we have e to the x. And then in our negative region, we just use this second case, and we take the negative, and we have e to the minus x. So then integrating this, we're going to have, integrating e to the minus x, we're just going to have minus e to the minus x evaluated from -1 to 0. And then integral of e to the x is just e to the x evaluated from 0 to 3. And we can plug in carefully. This is where you can really mess up your signs. So we plug in a 0 here, we're going to have a -1. Then we're going to have a minus, and then we plug a -1 in here, we get a +1. Plug in a -1, we have e, so we're going to have a minus e. But this is going to reverse the sign right here to a plus. Okay, and this one's easier. We're going to have, plugging in a 3, we're going to have e cubed minus e to the 0 is just 1. So then we just need to simplify all this. So let's see, we're going to have, take an e cubed here, and then we have an e over here. So we have e cubed plus e -1 -1 -2. That's it. Very quick integral, MIT 2013, problem 2.